Hello and welcome to the module on descriptive statistics. First, what are descriptive statistics? You can use them to describe your sample. You can use them to explain your findings. They are quantitative numbers in ways to discuss, again, your sample or your findings. So usually you can use descriptive statistics as counts or the straight number. And that's usually depicted as an N. You can use frequencies or percents. And then there are methods of central tendency, mean, median, mode, and range. And I'll go into those in just a bit. So first, when you use descriptive statistics to explain your sample, this is most often demographic data, and you use this to describe your human populations, again, your participants, your sample, your settings, which can be a school, a district, multiple schools or districts, cities, communities, etc. And I encourage you to take a look at figure 3.1 in Bernhardt. That's a very helpful table. And here is another, this is actually a screenshot from the Bernhardt book. These are just different ways that you can describe your sample numerically. So the number of students in the school, the number of students in the school with special needs, those who are English language learners, etc. So when you think about descriptive statistics, you also want to think about disaggregating data. And this is basically subgroups of your sample or subgroups of your participants. So you might start with the number of students in your school, and then you're interested in the number of students in the school in each grade, and then you're interested in gender within each grade, and then you're interested in whether students are eligible for free or reduced price lunch in each grade and how that varies by gender. So that's just an example of multiple ways that you can cut your data. So in this table, we are looking at counts, or again, N's. And here we can see the number of students in each grade, the number of students in each grade by gender, the number of students in who are eligible for free or reduced lunch, and the number of both boys and girls in each grade that are eligible for free or reduced lunch. And here, free or reduced lunch is one way of measuring income or socioeconomic status, which is why often educational researchers are interested in that as a variable or as a way of describing your sample. So this is a similar table, except here you can see we include both counts and percents. And it's important to think about what you want your reader to know about your sample and why counts or percents might be interesting or important. So first we can see that the N, or the number of students in each grade, varies across from grade 1 to grade 5. And we can see that first grade has the largest proportion of students out of the school. Again, so there's 112 students, and that is 22% of the entire school, which is 500 students. We see that in that very top row in the darker green. And then as we move down the rows, again, you can see that we're interested in gender. So if we keep our eye on first grade, there are 56 boys and 56 girls in this class. So it is actually split 50-50, and that's what those percents represent. And then as we get down to free or reduced lunch, we see that 76 students in grade 1 are eligible for free or reduced lunch. But instead of having that be out of 112 students, the 15% actually represents 76 students out of 500. So that denominator is actually different. Then we look at the last row, and we can see the number and percent of students who are eligible for free or reduced lunch based on their gender. So I want to give you just a minute to take a look at this table and think about where the counts or the percents might be important, and also where the different denominators make more sense. I do want to give just a note that you may not want to combine denominators in the same table. I did it here as a classroom exercise, but that might not be relevant or most easily interpretable from your reader as you present these types of data in a dissertation. So here is just another example as we think about percents and the counts. And the question here is, how many students saw their school counselor during drop-in hours? So out of the whole school, there's 3,860 students in the campus population, and 151 students saw their counselor during drop-in hours. So that is 3.9% of the whole school. But perhaps we're especially interested in how seniors use drop-in hours. Well, we can see that 131 students, or nearly 11% of the whole school, used drop-in hours. But maybe we're particularly interested in students who are in the STEM learning community. So we have 95 students who saw their counselor during drop-in hours, and that is roughly 7% of that population. But then if we look at the next line down, we have 71 students out of 370 students who are seniors and also in the STEM learning community. So the examples here are that as your denominator changes, your counts stay the same, but your frequencies may change based on who is in your base sample. So again, looking at that line, we have 71 students. So that's this, at this point, that's the smallest number of students we've discussed yet, but actually 19% of the community in which we are interested in, which is the seniors in the STEM learning community. And then if your school happened to have a Women in STEM initiative who are seniors, we would be interested in senior students who are women or female and who are in the STEM learning community. So we can see that 56% of students in that population went to their school counselor during drop-in office hours, but that actually represents, we're approaching a quarter of those students. So again, this is just a way to think about how the number of students and the proportion of students may be telling a slightly different story. We also need to think about measures of central tendency, and the first one is the average or the mean. So the mean is the total scores divided by the number of scores. So we add up score 1, score 2, score 3. We divide it by 3 because there are 3 scores, and in this example, we can see that the average is 44.3. It's important to know here, though, that a high score can skew your findings. So we have the same scores, and then we add a student who scored very high as 78. So that total is 211, and we divide it by 4. And now we can see that the average has shifted up pretty significantly from 44 all the way up to almost 53, right? So one score can actually skew the average pretty significantly. In the median, scores fall on either side of the middle. So to find the median, you actually arrange the scores in order. So if we start with the scores of 45, 47, and 41, we rearrange them in order, 41, 45, 47, and we can see that the median is 45. Again, that's the middle number, and there's an equal number of scores on the right and the left. If there is an even number of scores, then you take the median, or you take the average of the middle two scores. So we have arranged the scores in order, 41, 45, 47, and 48. And then the median is 45 plus 47 divided by 2, or 46. We also have the mode, which is the most frequent score. So out of our sample of 41, 45, and 47, there actually is no mode. But as you can see, once we add in some more numbers, 41, 45, 47, 48, 50, 41, 46, 41, the mode is 41. And then we also are interested in the range of scores, and you might think about when the range might be important. Well, you should actually be thinking about when any of these measures of central tendency are important. Perhaps you're interested in average grades, but you might also be interested in the high and low grades for the class. That might be particularly relevant when you're thinking about test scores. So in this sample that we have here, the range is 41 through 50. And another way of saying that is actually using it as a subtraction. And I see I have you can see I have it there. So if you subtract 50 or 41 from 50, then you could also say the range is 9. So both ways of representing the range are acceptable there. So I just wanted to spend a little bit of time discussing percent versus percentage point change. And this is a real life example. This image is taken from the graduation initiative for the California State University system overall. And if you're looking at that orange line there, that 6-year graduation rate goal, you can see that we've started at 57%. Right now we are at 62%, and our goal is 70% graduation rate for all first-time students after or by or before 6 years. So what I want you to just take note of here is that where we are now is 62%, but between 62% and 70% is a percentage point change of 8 percentage points. It's not 8%. And I know that might be a little bit confusing, but that's the correct language. So when you're thinking about a percent, you can say that. When you're thinking about a percentage point change, that is when you use subtraction. So again, 70% minus 62% is 8 percentage points. And you can think of percentage as a number or ratio of a fraction of 100. And so this is just a little bit more here. So again, percent means per 100, and the percent change is a different formula. It's usually conducted over time. So you can see that to calculate the percent change, you would have time 2 minus time 1 divided by the absolute value of time 1. And so that's how you can see in the table, we have an 8 percentage point change, but a 12.9% change. So again, that's just being a little bit of a stickler on that language, but it is important because they mean 2 different things. So as I wrap up here, I just want you to, again, think about when presenting a median, mode, or range might be most important, especially over and above mean, because we usually hear means or averages presented most commonly. So just think about that as you are not only describing your sample, but as you are using descriptive statistics to explain your findings once we get to that point in the dissertation. All right, thanks so much.